Hello and welcome. Today's our discussion is on classification versus clustering, and we will give you a very short overview about it. So let us see what is classification with the help of an illustration. If you ask what is this or what is this to a 5-year-old kid, he will immediately reply that this is an apple and this is an orange. So, what do we understand from this example? Basically, a 5-year-old boy can adapt and react to different objects. We want to teach similar adaptation to a machine to recognize and provide actions. So we can say that discriminatory power of humans or machines to recognize objects is classification. So now let us see what is clustering with the help of an example. If a bag of fruits given to us which are not so familiar, we can't do classification. However, can we arrange? As you can see, we found three distinct bags representing three clusters. This process is basically known as clustering. So let us see some more points about clustering. We may not have any prior information. That's one point. We want to arrange similar objects together and dissimilar objects in different clusters. Now let us see a quick overview of machine learning. It can be subdivided into two main categories: supervised learning and unsupervised learning. Classification falls under supervised learning, whereas clustering comes under unsupervised learning. For supervised learning, the state of nature, or we also call class labels, for each pattern or object is known, whereas for unsupervised learning, it is unknown. There are many techniques under supervised learning, such as linear discriminant analysis, nearest neighbor classifier, KNN classifier, neural networks, support vector machine, random forest, and so on. For unsupervised learning, there are also techniques such as independent component analysis, genetic algorithms, hierarchical clustering, K-means algorithm, and so on. Supervised learning generally divided into two subtasks. First one is training phase, also known as model estimation, and second one is testing phase, which is known as class labeling. Sometimes we also need another task, which is known as validation task. The validation task is performed to evaluate the model's fitness.
Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about k-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for k. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1. Select the number of clusters you want to identify in your data. This is the K in K-means clustering. In this case, we'll select K equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for K, but we'll talk about that later. Step 2. Randomly select 3 distinct data points. These are the initial clusters. Step 3. Measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4. Assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to Step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster, using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The K-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since K-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, K-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall, so it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for K? With this data, it's obvious that we should set K to 3, but other times it is not so clear. One way to decide is to just try different values for K. We'll start with K equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try K equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the 2 clusters to K equals 1. Now try K equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the 3 clusters to K equals 2. Now try K equals 4. The total variation within each cluster is less than when K equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before, and when there is only 1 point per cluster, the variation equals 0. However, if we plot the reduction in variance per value for K, there is a huge reduction in variation with K equals 3, but after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick K by finding the elbow in the plot. Question: how is k-means clustering different from hierarchical clustering? K-means clustering specifically tries to put the data into the number of clusters you tell it to. Hierarchical clustering just tells you, pairwise, what two things are most similar. Question: what if our data isn't plotted on a number line? Just like before, you pick 3 random points. And we use the Euclidean distance. In 2 dimensions, the Euclidean distance is the same thing as the Pythagorean theorem. Then, just like before, we assign the point to the nearest cluster. And just like before, we then calculate the center of each cluster and recluster. Bam! Although this looks good, the computer doesn't know that until it does the clustering a few more times. Question: what if my data is a heat map? Well, if we just have 2 samples, we can rename them X and Y. And we can then plot the data in an XY graph. Then we can cluster just like before. Note, we don't actually need to plot the data in order to cluster it. We just need to calculate the distances between things. When we have 2 samples, or 2 axes, the Euclidean distance is the square root of x squared plus y squared. When we have 3 samples, or 3 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared. And when we have 4 samples, or 4 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared plus a squared, etc., etc., etc.
Hello people, welcome to Geeks to Geeks. In this video, we'll be dealing with a customer segmentation dataset and performing k-means clustering to segregate customers based on the data in form of clusters. This is used in a variety of applications such as market segmentation, document clustering, and many more. After all, the goal is to get a meaningful intuition of the structure of data we are dealing with. So let's begin with the tutorial. In this problem, we'll be going under this process like understanding the data, then we'll perform elbow method to find the optimal number of clusters, then we'll train a model using unsupervised learning algorithm, that is k-means, and finally we'll plot the clusters and gain the intuitions from them. Coming towards understanding the data, in this section we'll be importing some useful libraries followed by reading our data. We will understand our data and find if any null values exist in our dataset, and finally prepare a subdata for our clustering purpose. So we'll be starting off this code by importing some important libraries such as importing pandas as PD, importing numpy as np. Sorry, it should be import, then import matplotlib, and import seaborn. So basically, pandas is mainly used for data analysis. Panda allows importing the data from various file formats such as CSV files, JSON, SQL, Microsoft Excel. Pandas allows various data manipulation operations such as merging, reshaping, selecting, as well as the data cleaning, and many more. While NumPy is a basic level external library in Python used for complex mathematical operations, while Matplotlib and Seaborn are amazing data visualization libraries which we'll be using to plot our elbow plots and clusters as well. Now we'll start importing our data. So basically for this tutorial, we'll be using mall customers data which is readily available on Kaggle. We'll import the data using df, which will be our variable in which we'll save our CSV file, pd.read_csv. Since we are importing a CSV file, we'll mention CSV here. Else, if the file is in Excel format, we'll read pd.read_excel and the file path in which we have saved our file, all customers.csv. Now, when we hit df.head, this will display the top 5 rows Now, if for example, if we want to display the top bottom rows, we will write df.tail and it will be giving the last 5 rows. Now we can mention the amount of rows we want to display. For example, if I want to display 10 rows, so I'll mention df.head 10 over here and we can get the top 10 rows over here. So let's first understand about our data. So we have customer ID, which is unique for each of the customer. We have gender, age, annual income, which is in $1,000, and the spending score, which ranges from 1 to 100. So if basically a customer is spending less amount of his salary or income, the spending score will be on lower side and vice versa. Now, in order to see the shape of our data set, we'll execute df.shape and we can see that the output is 200 comma 5, which means we have 200 rows and 5 columns. Now we will execute df.info. So this command basically displays a brief information about our data, which include the not null count, that is if there are any null values or not, the data type, what is the type of features, whether they are integers, float values or categorical values, etc. And finally the memory usage of our data. So let's execute the command and we can see that firstly we don't have any null values in our data set. We can see except gender column, all other columns have integer values while gender is categorical feature having object values. And also we can see that the memory usage is just 7.9 kbs. Now, as we are dealing with the unsupervised learning approach, here we will be plotting our clusters of customers based on the factors such as annual income and spending score. So what we'll do is create a separate data frame X and we'll execute X is equal to df dot ilock semicolon and 3 and 4 dot values. So Panda provides us a unique method to retrieve the rows from the data frame. The data frame ilock method is used to extract the column based on the index number. Here df.ilock 3, 4 represents extracting column numbers 3 and 4 and saving them in our new data frame, which is X. And now when we execute X, we'll be getting values of our annual income, which is our third column, and spending score, the fourth column, in form of arrays. As we are done with the first part, that is understanding the data and preparing the data for clustering, that is we separated the columns such as annual income and spending score in order to use them for customer segmentation. Now we'll be coming towards the second step, that is performing elbow method to find the optimal number of clusters. In this step, we'll be using k-means to iterate from 1 to 11 clusters and plotting an elbow plot out of it and decide the optimal number of clusters to be used for our customer segmentation. Before starting, let's understand what is elbow method and k-means. So basically, elbow method is fundamental step for any unsupervised learning algorithm to determine the optimal number of clusters into which the data may be clustered. Also, it's one of the most popular method to determine its optimal value of k. When we plot the line chart, it resembles the arm and the elbow, that is the point of inflection on a curve, which is a good indication that the underlying model fits best at that point, which is optimal number of clusters. Coming towards k-mean algorithm, k-mean clustering is an unsupervised learning algorithm which groups the unlabeled dataset into different clusters. Here the letter k defines the number of predefined clusters that need to be created in the process. As if k is equal to 2, there will be 2 clusters, and for k is equal to 3, there will be 3 clusters, and so on. It allows us to cluster the data into different groups and convenient way to discover the categories of groups in the unlabeled dataset on its own without any need of training. We will be starting off by importing k-means from sklearn.cluster. So from sklearn.cluster import k-mean And also we'll be creating a blank list, say WCSS, and we'll execute this. Now for each value of k, we are calculating WCSS, which stands for within cluster sum of square. WCSS is the sum of squared distance between each point and the centroid in a cluster. When we plot the WCSS with the k value, the plot looks like a elbow. As the number of cluster increases, the WCSS value will start to decrease. WCSS value is largest when k is equal to 1. Now, we will be using a loop to find out the optimal value of k using a elbow method. Now, for that particular purpose, we will be using this static code. Basically, this iterates the k-mean algorithm for our data for I iterations from 1 to 11. Since we assume that maximum clusters possible would not be more than 10, here we are using initializer as k-means plus plus. This means k-means plus plus algorithm ensures a smarter initialization of the centroids and improves the quality of clustering. Basically, k-mean plus plus is a standard k-means algorithm coupled with a smarter initialization of centroids. In this code, k-means inertia is a formula used to segregate the data points into clusters. Now it's time to display our elbow plot, and how can we do it? So we'll be using matplotlib. So we'll be executing plt.plot range, comma 1 to 11, comma WCSS. Now we'll be also adding the title to our plot, plt.title, that is the elbow method. You can change it as you want. Also, we'll add the X labels and Y labels, which will name the X label as number of clusters and Y label as WCSS values. And finally, we'll be executing plt.show. Now, after executing, we can see a plot has been displayed. Now here we can see that the plot reduces drastically from cluster number 1 to cluster number 3, slows down till 5 and flattens from 6 to 10. We can see that we are getting an elbow at k is equal to 5, which means finally the optimal number of clusters can be assigned as 5. So no matter what range we select, say if we select a range from 1 to 21, we'll see the same behavior. Once we are done performing the elbow method to find the optimal number of clusters, we'll be moving towards the next section, which is training a model using unsupervised learning algorithm, which is k-means. So here we'll be initializing our k-means model with a selected optimal number of clusters, and we'll plot the clusters and gain intuition regarding our customer segmentation. Now once we have got the optimal number of clusters, which is 5, we'll start building our model now. So we'll create a variable k-means model is equal to k-means, where n clusters will be assigned as 5. Then init, that is initializer, will be k-means plus plus, as we explained before, and random state will be equal to 0. Now once we are done initializing our model, it's time to use this model for making our predictions. So how can we do that? So k-means is equal to k-means model dot fit predict and our data x. So x is our data, which includes the salary, annual salary, and the spending score, and we'll be saving these predictions into a separate variable yk-means. So let's execute this. Now once we are done storing these predictions in yk-means, it's time to plot all our clusters. So here we'll be using scatterplot for that purpose. So I have written the code already for plotting our first cluster. So here plt.scatter means the scatter plot. Then we'll feed the sparse matrix of our outputs, that is x, which is our data, and the k-means 0 0 and k-means 0 comma 1 represents the matrix of output cluster. S represents the size of clusters. You can change it as you wish, and we'll mention the color as well. So for first cluster, I've given the color red and label as customer number 1. So we'll just copy this line of code for all the 5 clusters we have generated. So we'll be giving customer number 2, customer number 3, customer 4 and customer number 5 for each of the unique clusters. And also we'll be giving unique color such as blue, we have yellow, we have can, and we have black. And also we'll be changing these coordinates such as 1 0 and 1 1. Here it will be 2 0, 3 0 and 4 0, while here it will be 2 1, 3 1 and 4 1. Now apart from plotting these scatter plots to display our all 5 clusters, to make it more informative, I'll be also adding the code for plotting the cluster centers, that is centroids of clusters. So basically here the cluster center will plot the centroids for each of the cluster present, and also will mention the size as 100, which is a bit larger than the normal clusters, and color will be magenta, and will label these as centroids. We'll be also adding plt.title as clusters of customers, plt.x label as annual income, and y label as our spending score. We'll be also adding the legend in our plot, and finally we'll be displaying the plot by executing plt.show. As you can see, a beautiful plot has been displayed. So what are the intuitions we can extract from this plot? We can see that a blue cluster on the top left side represents the customers having comparatively less salary, but their spending is quite high. On the other side, we have black cluster, which represents customers whose annual salary is quite high, but their spending is comparatively less. Now, for any company, the people from this red cluster are the target audience. Since the maximum people are included in this red cluster, also they have decent salary and their spending is also quite well. So the company will promote their products more with the customers included in red cluster than the customers included in other clusters. Well, this is the most important intuitions which is extracted by a lot of companies to target their customers based on the available data. But yeah, the practical data will be a lot more complex, but the basic principle of clustering remains the same. Well, this was all from my side, and thank you so much for watching the video.